Well, here we are, you guys, working on, this should be day 1, adding and subtracting polynomials. Some of you already know how to do this, so if you do, hopefully you're not wasting your time watching the video and just do this on your own. Otherwise, hang tight. I'm not going to go over every question, but I'll go over the ones that I feel are necessary, and then your job is to complete the rest on your own and submit it as an assignment. So the first thing we're going to talk about is what is a polynomial, because this unit, the next 7 days, are all about polynomials. So what makes something a polynomial? Well, there's 3 things. The polynomial cannot have any negative exponents. The minute you see one, that means it's not a polynomial anymore, because what a negative exponent does is it makes something, reciprocate something. So if we had something where it was x to the negative third, that really is 1 over x to the third. And that is called a rational expression. So that no longer is a polynomial. So that's the first thing. It can't have any negative exponents. The second is that the exponent must be a whole number. We talked about this a few units ago. If it's not a whole number, which means it's a fraction, so say we have x to the 1/2. Remember I said that was the one that you want to remember because it helps you with all the rest. X to the 1/2 is really the square root of x, which is a radical. And so that's why that's not a polynomial. The last thing, it doesn't have roots, which is the square root that I just talked about, or absolute value, because each of those are different kinds of functions. So these are specifically polynomial functions, which means terms added or subtracted in which they don't have any of those 3 characteristics that I just talked about. So the first goal for today is to determine whether or not we have a polynomial. So we're going to look at that. Once we identify if it is a polynomial, we're going to state the degree. So if you don't remember what the degree is the highest exponent. And then if it's not a polynomial, you would explain why using one of these 3 reasons up above. So there are 6 little questions here. I'll go over 3, you guys do 3, and we'll move on. So we're going to do together, let's see, how about A. We will do together D, and we'll do together E. And then you guys will be in charge of B, C, and F. So the first one, is this a polynomial function? So we'll go through our 3 things really quick. Does it have any negative exponents? Nope, looks like we're good. The exponents have whole numbers. It looks like it is. And does it have roots or absolute values? It doesn't. Here's the only thing. I said yes to the fact that it has no negative exponents. It doesn't, technically, when I look at it. But when I look at this first term, 1 over x, that really means x to the negative first. So really, this would have a negative exponent. So because that has a negative exponent, it is not a polynomial. So I'm going to say no. Why? Because it has a negative exponent. Okay? So even though we don't see it, that 1 over x means that it is a negative exponent. If x is in the denominator, that means that the exponent has to be negative. So let's look at D. So let's check. Any negative exponents? Well, let's see. I have a fraction here, but it's the 1/2. And so that's okay because that's a coefficient. And then it has x squared, 3, and 4. So we're good there. All the exponents are whole numbers. 2, 3, and 4. And it does not have a square root or an absolute value. So we're good there. So we would say yes. This is a polynomial. So in this case, to find the degree, which is the highest exponent, this is an interesting one because it has 2 variables. So I'm glad we picked this one to go over together. If there are 2 variables, it's not just the highest exponent, because which variable would it be of? If there are 2 variables, you add the exponents, and then you find the degree. So in this case, let me zoom in a bit. The exponent here is 2 for the x and 3 for the y, so I would add those, so that would really be 5, and then this one has a 4. So the degree, because there are 2 variables, we added those 2 together. The degree is 5, and so that's how we would answer that one. If it was only x's, then I would just look for the highest x value. So let's say that in this case, there was no y, let's say, and it was just x squared and x to the 4th, it would be 4 because there's one variable, so you take the highest exponent. All right, for part E, we'll go through our questions again. First question, is there a negative exponent? 3 and the square root. I don't see a negative exponent, but again, as long as x is in the numerator, we're good, and in this case it is. X has a whole number as the exponent. This one does, but this one, remember, square root of x is really x to the 1/2, so that would be a no. And then also because number 3 says there can't be a square root. So this case, it would be no. And I would say why? Because we could say 2 things. Exponent is not a whole number, or that would be one option, or there's a square root, either one. All right, so that's the first part of the notes. What I want you guys to try is B, C, and F. Those are the 3 I'm looking for when I check your completion. And then once you're done with that, move on to the second part, and which is adding and subtracting. I'll see you there in a minute. All right, so hopefully you guys finished up those 3 questions, or just continue this video and are going to finish them at the end, whatever your preference is. So we're moving on to adding and subtracting, and really it is what it says it is. It's adding and subtracting like terms, really. So we're looking for like terms when we do these. And when we look for like terms, all we do is we count them. The exponent doesn't change when you're adding and subtracting. We're just counting if there's, 3x squareds plus 5x squareds. We count 3 and 5. That's 8x squareds. The only ones you have to be careful of are the subtraction ones. There's a little step that you have to do first. But other than that, it's pretty straightforward. So I think I'll just go over 1 adding and 1 subtracting, and then you guys can try the rest, and if you have questions, just let me know, because I think these are pretty straightforward. You guys are smarty pants, so you should be able to figure this out with just 2 examples completed. So the first one, let's go over A together, and then we'll go over C together, and then the rest will be for you guys to complete, which shouldn't take too long. So the first one, how do I know what operation is happening? So I have one group of terms here, and then I have another group of terms there, separated in the middle by an addition symbol. So that's how I know what operation is happening. Once I identify the operation, then I look for like terms. So I like to underline and circle and box. So I have a 4x squared here. I look in my second set of terms, and I have a 3x squared over there. So I would combine those, and I would say I have 4x squareds plus 3x squareds in a total of 7x squareds. Then I move on to the next term. I have a 5x squared, or I'm sorry, a 5x plus a 7x, which, if we count that together, gives us 12x's, and it's positive, so I put it plus 12x. Last one, I have a negative 2, that's my constant, does not have a variable. I'm going to put that together with my other constant, minus 4. So I have negative 2 plus a negative 4. Because they're both negative, we add those 2 terms together. 2 plus 4 is 6, and they were both negative, so it stays negative. So there is my final answer in the correct order, ascending order from highest exponent all the way to my constant. Descending, I meant, not ascending, descending. All right, so part C. First set, second set. How are they separated? By subtraction this time. So there's one extra step involved. After this first step, everything is the same as above. So subtracting, what am I subtracting? Well, we have 3 terms in this set of parentheses that we're subtracting. So what that means is each one of those signs is going to change. So 3x squared minus 3x minus 4, that all stays the same. I didn't like how I wrote that. Once I start changing the symbols of the other one, my subtraction goes away. So I'm going to subtract a negative x squared, so it'll become plus a negative x squared. Then I'm going to distribute that to the 9x to become plus 9x, and then I'm going to distribute that to our constant, becomes minus 5. So now again, I distributed that to each one of these terms, changing the sign of each. And now I look for like terms. 3x squared plus a negative x squared or minus an x squared gives us 2x squared. I have a negative 3x, and then I have a plus a 9x, which gives us 6x's. And then a negative 4 minus 5 more gives us minus 9. So that's the only thing. Subtraction, you have to distribute. That is the only catch here. All right, so we went over a few things. We went over how do we tell it's a polynomial? No negative exponents. They all have to be whole numbers as exponents. It can't have a square root or an absolute value. The degree was the highest exponent, and if there's multiple terms, you add them together. And then we talked about adding and subtracting. Adding was straightforward. We just combine like terms. Subtracting, we got to distribute first, and then we combine our like terms. So I'm going to ask that you guys complete the rest of this worksheet, which should not take you that long, and then submit it under the assignment. And I'd be happy to answer any questions you guys have.